Hi, I'm Dave Baring, Technical Director here at TriStar, and welcome to another Tech Talk. Today I'm going to talk about high performance materials, which can also be classified as high temperature materials. They're really one and the same. And when we talk about high temperature or high performance, we're talking about materials that are designed to operate continuously at 300 degrees and above. Now, that doesn't seem like a lot, but when you're talking about plastics, which are really designed to melt, 300 degrees is a pretty good temperature. And some of the materials we'll be talking about today are capable of even going up into the 700s and 800s and even higher in short-term exposures. So, first of all, there are a couple of different classifications of high performance or high temperature materials. First, and at the top of the heap, is the imidized materials. This would be materials like PBI, which is polybenzimidazole, also known as Selazol, the polyimides, which would be things like Meldon or Vespel, and then Torlon, which is another imidized material. It's polyamide-imide. These are all materials that have a very, very interesting classification because of that imide content. Below that, we have materials that are basically functional up into the 400s and 500 degrees, things like your PTFE materials like Rulons and fluorescent. It also includes some of your PEEK materials. And then you move down the triangle a little bit further and we get into PPS, which is like Riton, the sulfones, Ultem. These are all materials that are classified as high temperature and high performance. Now, what qualifies a material to be a high performance product is that they have some very distinctive features. First and foremost is that these materials are very strong materials for the most part and are able to maintain their physical properties over a much broader temperature range than, say, an engineering plastic or commodity plastic. So when we look at these products, we're really looking at their thermal properties, their physical strengths, what are their inherent tribological or frictional properties, and then try and match those up with the particular environment that they're going to be exposed to. Some of these materials, like your PTFE-based materials, are, for all intents and purposes, completely inert from any chemical attack. So those would be materials that if you're operating in the 500, 550 degree range, PTFE material would be a very good call for your application. The imidized materials perform extremely well in air, especially in dry conditions, where your temperatures are going to be in the 600, 700 degree range. PBI can even go as high as 1100 degrees in short-term exposure. So, you know, all of these materials have their place. And as you can imagine, when you put a moniker on anything that says high performance, you can pretty much count on that material being high cost. And we're talking in terms of, if you use nylon, for instance, as a baseline at $1, PBI or Selazol would be upwards of $200. And it kind of stair steps down, you know, looking again at the triangle we started with. These are pretty typical of costs, you know, 200 down to 100, down to 70, down to 50, but they're all going to be materials that are extremely high cost compared to a Delrin or a nylon or something of that nature. So, high performance materials, high temperature materials, stability, so many different quality factors that come into play with these materials. So we take a look at each one relative to your application. Just to throw out a material that works at 450 or 500 degrees doesn't necessarily work all the time. So we need to, again, talk with you about all of your parameters and work to select the right material to give you the best performance and optimize that extra cost you're going to be paying. We do have a section on our website that I would direct you to, and that is our advanced material search. You can go on there and look at some of these high-end materials, again, the PEEKs, the PTFE materials like Rulons and fluorescents, Torlon, your polyimides, PBI, your sulfones. All of these materials would fall into the upper end of the plastics world, and each one has its place. Otherwise, there wouldn't be so many of them. So we'll be happy to work with you on the selection process and be sure you get the right material for the application. Thanks again for joining us, and we look forward to seeing you in another Tech Talk.